this is Pete from PA Labs, and I'm picking up with our super deep dive video 2 into the flood fill. And so we now have a full understanding of the terrain grid and the array, which is of type layer hex of the layer hex object, each layer hex having a collection of the details inside. Okay, now for flood fill, everything is done based on hexes. Okay, so it's no wonder we have a structure which is hex, and hex has 3 fields. It ended up with 3 fields, row and column for sure, and then terrain cost. Okay, and terrain cost is used to track the terrain for individual hexes, which is used somewhere else for dealing with other things. But we'll get to all of that. Just know that we track the terrain cost with the hex object. All right, now a vector. A vector is a delta. It is a what is the change in row, what is the change in column to move from one hex to another, okay? So again, we come back here and I say, let's not draw on this. We can just add another layer on it. And I can come over here and say, if I am, I don't want to use that. Okay. That ought to be good enough. If I am here, okay, and I want to move here, what do I got to do? So this hex here is hex 1, 1. If I move here, this hex is 0, 0. All right, so I have to do a -1, -1, correct? I have to subtract 1 from the row and subtract 1 from the column to move northeast from my current hex, okay? Now, that changes if I was down here and I am on a even hex here and I move in the same direction, I go northeast. Now, the hex I am in is column 3 and row 3. So I'm going to move to column 3, row 2. So there's a difference because of the hex I'm sitting on. My vector, the difference to make the same move is different, okay? And that is because of this offset up here of the grid. Now, the offset of the grid, if you'll remember, is even parity, odd parity. Yes, 0 is even, so it's 0, 1, 2 is even, 4 is even, 6. Okay, so depending on the parity, the even or odd, of where you are sitting on the grid, the vector, the delta difference, is different to move in the same direction. And that's an important thing to get into your head. So what we've done is we have a vector object that is going to hold the deltas, the -1 or +1 or 0 of moving from one hex to another hex in a direction. Okay, so now we define direction. It's our own enumeration. It goes from 0 to 5 because there's 6 directions on a hex. And we go southeast, northeast, north, northwest, southwest, south. Okay? And the order is the order, and I pulled it straight from the website that I pointed out at the beginning. Parity is even or odd column parity, okay? So now, Directional differences. Here's the first of the functions that is very, very important. And this is the underlying mechanics that begins to make this work. So get the directional difference. What we're doing is you give me a parity, and this is the even or odd column that you're going from, and you give me a direction that you want to go. And I am going to load up your vector that you hand me a link to with the even or odd direction. Okay, so it'll be 1, 1, 0, 1. These are the various values for the two different parities. If the parity is even, you're on 0, 2, 4, 6, and down here, otherwise you're on 1, 3, 5, 7, that kind of thing. And this is the math to get to the next direction, to go that direction. All right. Now, this all just starts to begin to stack. Okay. We have a function that says, I need the offset neighbor. Okay. That's cool. You give me this is going to load an object of type hex that you have to give me. You give me a hex with where you are and tell me what direction you want to go, and I will load this hex with the coordinates of that direction. Okay, so if we are, jump back here. If I am sitting here at 2, 2 and want to go north, west, then I would give him an object with 2, 2 and tell him we're going northwest, and he's going to load that object with this guy's coordinates for me. Okay, so you don't want to pass him the actual guy you're using yet. We're just looking it up. And what we're going to do is normally what we're after is we're sitting here and I want to spin these 6 directions and get the movement and get the location of each of these 6 cells and find out what their terrain cost is. And then look at my unit and say, hey, I can move there. All right. And then what we're going to do, this is the basis of how this works at a very high level, and I hope you can follow. So how the flood fill works is he starts looking at where you are, and then he loads an array or a collection, a list or whatever of these 6 hexes. Okay. And assuming you have the movement to move from here to here, then I create a new array centered on this guy, and then I go look at these 6 hexes, okay, and see if you still have movement to move to any of these, making sure that I haven't already been there, okay, and let's say we get to this hex. Then we start a new list, and we look at the surrounding hexes of his 6, and so on and so forth, until we exhaust all of the movement capabilities of the unit in question. So with each iteration, we started a cell, we look at all 6 surrounding cells, and then we take each of the 6 surrounding cells and repeat the process, okay? So from here, our first layer, this is what's called the fringes collection. The fringes collection contains this hex, and it has a list of these 6 hexes. And then I create a fringe for each of these 6 hexes, which has a list individually of those guys, each of these guys' surrounding 6 hexes. Okay? And then I take a third layer and we go out to him and we do the same thing over and over and over. Okay. So important, that's how this is working. So you have a hex, you have a vector that is the delta between that hex and any of its neighbors. Okay. And then what we're doing is we have a function that says, give me the neighbor, and he returns this hex in the northeast direction, and then his surrounding 6 hexes we start over with. Okay, so these are the individual functions that we're going to be calling. So you give me a starting point hex and give me a direction, and I take that starting point hex, I go look up his vector, I do a call to the directional differences with that hex's parity and the direction you asked to go. I load up the vector, I add him in here, and then I clear the vector. Okay, so, and we just kind of keep going from here. So this is offset neighbor. I'm not sure that I use this one, or this guy is the guy who calls offset. So you can say, give me the from hex, give me a direction, and give me the destination. So from my source hex, I want to go northeast, and I want you to load this guy, this hex object here with that guy northeast. So we take the northeast guy, we set him equal to the from hex. We then call the offset neighbor with with our destination hex and direction, and he goes and looks it up. These functions cycle between themselves really, really, really fast and do a wonderful job. Now we have this is steps. Okay, the structure steps. This is the fringe object structure. Okay, he has he's this hex, and he has a list of these 6 hexes. This structure here, this fringe step here will have him, and then these surrounding 6 hexes. This particular hex would then be a fringe hex, and he has these. So I called this steps because we start here, and then I move here and repeat the cycle. Then I move here and repeat the cycle. So these are steps that I'm taking in this, and I'm picking up the fringe records around each of my steps. There's the logic behind steps. So steps is keeping a cumulative movement cost. Okay? To get to that center hex, that step, he takes the way back up here, the terrain cost of each of the former steps. Okay? So what we're going to do is start here with our hex. This hex has a movement that say woods are 2, foliage is 2 for our unit. So that fringe, this fringe step, our initial fringe step here, has a movement cost of 2, and he has a list of these 6 hexes. Now, if I go to each of these 6 now become fringe steps, each one containing his math, his 2 points, plus his 2 points. So your center, this step is costed to get to here is 4. And he has a list of these 6 steps. Okay? Now, each one of these steps now costs 6 to get to. So then if we look at this fringe here, this third fringe of this one path, these 6 surrounding guys, he's going to be 8. He'll be 7. He'll be 7. And since this guy has already been picked up, these 2 other guys don't exist in his fringe neither does his source. So this fringe only contains hexes I have yet to be at, and we take the cumulative math as we're stepping through. That's what steps movement cost is. That is a cumulative of math to get to that point. We're going to skip over zone of control. At the moment, I'm going to skip over the movement cost because where I'm leading in this is directly to the flood fill, which for whatever reason, the website where I got all this, that hex website with all the Python code, called this hex reachable. Can't actually answer why. I guess because you're only going to highlight the reachable hex, but the math of this is really called a flood fill, the processing logic. And now let's walk through this code because this is where all of that takes place. So we start with a starting hex. This is your unit sitting on the grid that you've clicked, okay? We pick up the game unit because I need to know the unit type and various aspects of the unit. And then what we're going to load and return is the list of visited hexes, okay? And then also for lookups and whatnot, I also need a link, a reference to the actual map. Okay, now, okay, we're ready for this, right? So we keep track of movement. Movement is part of the unit. The game unit has a certain movement. And then for this turn, he has used 1 point, he's used 2 points, whatever movement that's when at the end of the production, part of the production cycle is to reset that to 0. So his movement goes back to whatever his full movement is. All right. Now, I wanted to not mess with pointers. I wanted this to use actual objects because we have to pass them all over, and it just made more logical sense to me. And so what we've done is all this is doing is saying this is where we start. The terrain cost of this being in this cell is 0. That's our originating cell where we're sitting here and I want to move from here. To be in that cell costs me nothing. All right, now we're over here. We get his, and we're loading him now into our visited collection. So we've been there. Nobody else can touch that hex. And now we start our list of fringes. So the fringes are the 6 surrounding hex to some hex, okay? And that is a type of steps. So these are the steps we're going to take from starting, and we're going to step outward. Now, step has a list, and the list is of type hex, and it will contain, our first step will contain the 6 surrounding hexes, assuming you're not on an edge row. If you're on an edge row and you're moving, you can't move off the map, obviously. Okay, so ideally, you're starting here, and it will now fringe of step 0 or fringe 0 will contain these 6 hexes. Obviously, if you're on this hex, he only contains these 3, okay? That actually was a tweak I had to put in to make sure that you're not leaving the map. So anyhow, okay, so we've added our starting point. We've created a list of fringes. Each record in the fringe has its list of surrounding hexes. Okay, now, so folks, I need to break the video here because of length. I want to thank you for watching and stay tuned for the next episode.